are so many different topics that happen about the same time in inferential statistics that it's really important to try to think through a process to help you determine what type of question you have and then what it is that you need to do to answer that question. What I'm going to do in this video is to walk you through kind of a thought process, a mind map per se, so that you can kind of get an idea of how you need to think about and look at questions to determine which of the methods to do. Now, I know this is very little because there's so much that I wanted to put out there for you. So at some point in time, you may want to stop the video and try to see if you can zoom in on parts of it and actually copy this down for yourself. I will also try to attach it to the video so that it'd be a file that you could download and then look at as you're going through the process. So when we're looking at inferential statistics, and we're at the point that we've covered some information on sampling distributions and confidence intervals and probability and sample size and hypothesis tests, it's all happening at about the same time. So the first thing you really need to do is to read the question really carefully and find out what it wants you to do in the process of the question. So many of these problems will have exactly the same type of setup. So it's not how they give you the information that helps you determine what you need to do. It's what they are actually asking you to find. And I will also let you know that the way we're going to go about answering these questions on the ends of these branches do deal with the operations that are in a TI-83 or 84 calculator. If you're in a class or in a situation where you're not using the TI-83 or 84, you can still use this idea to find out what type of question you have, but then at the ends of the branches you'll want to write in your formulas or the operations that you would use in your statistical software package that you're using. All right, so once we look at the question, we need to ask ourselves, are they asking me to describe a sampling distribution, or are they asking me to find the probability that something's occurring, or are they asking me to find a confidence interval for a particular parameter? Are they asking me how many if it's a sample size question, or are they asking me to do a hypothesis test? So again, you read through the setup, but you need to look at what it's asking you for. Now, if it's asking you for a description of a sampling distribution, describe the sampling distribution, find the sampling distribution, that sort of thing, then the next thing you need to ask yourself is, are they asking you about the sampling distribution for the sample mean or the sampling distribution for the sample proportion? If it's the sample mean, you need to say the shape, the center, the spread. So if you're asked a question to describe the sampling distribution of a sample mean or find the sampling distribution for a sample mean, and your individual numbers were normally distributed, then the shape of your sampling distribution x bar is also normally distributed. If you don't know about the sampling distribution of the x's individually, but you have a sample size that's 30 or more, by the central limit theorem, then we would have that the sample means distribution is approximately normal, no matter what the distribution of the original x's is. Now, the center, the population mean of the sample means, is the same as the population mean of the individual values. So mu sub x bar is the same as mu. And the spread, sigma sub x bar, is the standard deviation of the individual numbers divided by the square root of how many you had in your sample. So sigma divided by the square root of n. If your sampling distribution is for p hat, then you're checking to see if n times p times q is greater than or equal to 10 to see if the distribution of the p hats is normal. If you do have that, then the distribution is normal for the shape. The center, mu sub p hat, is p, and the spread, sigma sub p hat, is the square root of pq over n. Now let's say it's asking you to find a probability. Well, if they're asking you to find a probability, and it's in the part where you're looking at a distribution, if you want a probability of individual number that is a normal distribution, so what's the probability that a value selected at random from a normal distribution is like less than a number or between numbers or greater than a number. Then you're going to use the normal CDF key, which if you have a menu option, it'll ask you for the low, then the high, then the mean, then the standard deviation. Or if you just have normal CDF with an open parentheses, that's how you want to enter it. The low number you're interested in, finding the probability, the high number you're interested in, finding the probability, that span, then the mean, then the standard deviation. And remember, to get to the normal CDF option on the TI 83 or 84, you push the second button and then the key that says VARS on the key and DISTR above the key on the board of the calculator. That key is next to the clear button. If your probability is for a sample mean, so if there's a bar over the X in the question of the probability, and you've checked and either the X's that sample was grabbed from is normally distributed or your sample size is greater than or equal to 30, then it'll be normal CDF again, low, comma, high, comma, mean of the sample means, which is mu. But the standard deviation of the sample means is sigma divided by the square root of n. So make sure you do that if you're finding the probability of X bar. That's a place where a lot of people forget to do and then end up not getting the correct values for that. Now, if you're doing the probability of P hat, check to see if P times Q and n times P times Q is greater than or equal to 10. If it is, then you can do the normal CDF, low, comma, of the P hat you're interested in. Make sure you're not doing the number of successes here. You're doing the P hat low, so the proportion that you're interested in. High P hat, and then P, the population proportion, and then the standard deviation of the P hats is the square root of P times Q divided by n. If your NPQ is not greater than or equal to 10, if it's less than 10, then you're going to go to the binomial probability distribution and use your binomial CDF or PDF, whichever the case calls for. That's the probability. Let's say your question asks for a confidence interval. So there you need to find out if you sampled from one group or if you sampled from two groups. If you sampled from one group and it's for a proportion, you're going to do the 1 prop z int. To get to that, you go stat, cursor over to tests, and then find past the tests, go to the 1 prop z int. If you sampled from one group and you want a confidence interval for a variance or a standard deviation, that doesn't have an software package to find those in the 83 or 84, so you actually do have to use the formula. For variance, you need n minus 1 in parentheses times your sample standard deviation squared, which would also be your sample variance. Divide by off the chi-squared table chart, the chi-squared upper for your level of confidence and your degrees and your also your degrees of freedom. And remember, your degrees of freedom is n minus 1 for this case. 2 n minus 1 s squared over chi-squared, so blower. Now remember, the chi-square distribution is not symmetric. So when you go to get these values off the table, you need to find them individually. They'll be different numbers and they will both be positive numbers. You can look at one of my other videos of reading the critical values for chi-square. Standard deviation is just the square root of the variance. So it's just this formula with a square root on it as you go. And then a confidence interval for the mean is t interval. Again, go stat, tests, all the way past the tests down to the intervals and do t interval. Sampling from two groups, if they're dependent, if they're in matched pairs, you're going to subtract the numbers in the pairings and do a t interval of the differences. If you're sampling from two groups and they're mean and it's independent, you're going to either have the specific statistics that they've given you or put all the data from the first group in L1 and all the data from the second group in L2 and do the data option. But then it's to samp t int for that and pick not pooled. For proportions, you do the 2 prop z int. Now with sample size, if it's a how many, if it's a sample size for the mean, the formula is n equals the quantity z sub alpha over 2 times s divided by e, that quantity squared. If it's a sample size for the proportion with a preliminary estimate for your p hat, it's p hat times q hat times the quantity z sub alpha over 2 divided by e squared. Without a prelim, n is 0.25 times the quantity z sub alpha over 2 divided by e quantity squared. And then if it's for the variance, you go to a table. Now with sample size, my n has to be found to be a whole number, and you round up. Not nearest, but up. Lastly, for the hypothesis test, if you sample from one group and do a proportion, you want to set up your null and alternate hypothesis using the correct symbol for the proportion parameter. Your null is always an equal to, so p equal the number, and your alternate is either p is less than that same number, they match, or not equal to or greater than. If you're doing the traditional method, your critical value is from the t inverse norm process. And to get your test statistic, you can go to the 1 prop z test. And that would also give you your p value as well. If it's for the mean, it's mu for your symbol in your null hypothesis is equal to a number. And then in your alternate hypothesis, mu is less than a number or not equal to a number or greater than the number, depending on which your problem needs. Your critical values from the t table, so you get that from the inverse t if you have it on your calculator, or the t table if you have to look at a table. And your degrees of freedom are n minus 1. For variance or standard deviation, your null is sigma is equal to number, and then your alternate is sigma is less than, not equal to, or greater than that same number. Your critical values are from the chi-square distribution, degrees of freedom is n minus 1, and your test statistic is chi-squared equals n minus 1 times s squared over sigma sub 0 squared. Now this sub 0 means you get the number from the null hypothesis. That's what that sub 0 is. And if this is with sigma, whatever that number is, you've got to square it for down here. And then sample from 2 groups. If they're independent, your null is mu sub 1 equals mu sub 2. So look how different it is in terms of your null and alternate hypothesis between sampling from 1 group and sampling from 2 groups. Then H1 is mu sub 1 is less than mu sub 2 or not equal to or greater than 2 samp t-test. 2 means dependent, you subtract in the matched pairs and get your differences, and the null is mu sub d is equal to 0, and then your alternate is mu sub d either less than 0, not equal to 0, or greater than 0, and you use a t-test on those differences. And then finally, for the 2 proportions, h sub 0 is p1 equal p2, and the alternate hypothesis is whether p1 is less than p2, not equal to p2, or greater than p2. Now, when you're looking at the hypothesis testing, if you're working with the traditional method, you're going to draw your sketch. It's going to look like this if your alternate is a less than, and that's called a left tail test. Your diagram is going to look like this with the 2 regions shaded if it's a not equal to in your alternate hypothesis. Usually in the hypothesis test question it says something like is different from or is in your question. And so this is a 2-tail test. And when you set up the areas in these regions, you have to put an alpha over 2. You got to divide your alpha by 2 in each of those regions. But when you just have 1 tail, the full amount of the alpha is in that tail. And then if your alternate is a greater than, you're going to put all the area in the right tail, so that's called a right tail test. Now, if you're working with the way of making your decision with your hypothesis test by a p-value method, the p-value will be reported to you in the different tests that you do. If your p-value is smaller than your alpha, then you reject the null. If the p-value is bigger than or equal to your alpha, then you don't reject the null. And then I need to come back to the traditional method and just say one more thing about this. Once you have your diagrams, think of this bottom part as a number line. Your cutoff right between the shaded and the open, right between the rejection region and the part where you don't reject the null, that's where you put your critical value number. And when you get your test statistic, it's on this number line. And if the number from your test statistic is under the shaded region on the diagram, you reject the null. And if your number for your test statistic is under the open, you don't reject the null. Now, we're going to do one example, because with all of the other stuff going through, it takes quite a while to get through the information. But we're going to do one example and just see how to use this chart. So this says the average claim paid for a sample of 150 similar accidents was $1,545 with a standard deviation of $115. Find a 95% confidence interval for the population mean claimant payment for this type of accident. So you want a 95% confidence interval for the population mean. So when I look at my question, they didn't ask me to describe a sampling distribution. They didn't ask me to find population or a probability. They did ask me to find a confidence interval, so I'm under this bubble. Now, they just sampled from one group, so I'm going to go left on this branch. And then the confidence interval is for the mean. So I'm coming over, after I'm down off of sampling from one group, I come to the right to find mean. And at the end of that branch, it says t interval. So I'm going to go to the t interval. And with the t interval, it's going to ask me if I have data or stats. And I have the stats because I have the figured out values for the mean and the standard deviation, and they told me the sample size. And then it's going to ask me for x bar, and that's the sample mean. So the average claim was that $1,545. And then it's going to ask me for s sub x. That's the sample standard deviation. So here the sample standard deviation was 115. Next up, it asks for n. N is the number in my sample, so that's 150. And then for C level, that is my 95% confidence level, so I put 0.95. And then there's calculate, so I cursor down and push the button for calculate. And it's going to give you a low number to a high number in parentheses, and then it's going to reiterate the sample mean, the sample standard deviation, and the sample size, so that you can just like look at it and double check and make sure you have it right. Now, we always want to write a sentence so that we get this information to the person with meaning for that setup. And when you write a sentence for the confidence intervals, just take off the word find and capitalize the next letter. So this is a 95% confidence interval for the population mean claimed payment is, and then from looking looking at your calculator, it's $1,526.40 to $1,563.60. And this unit is in money because we're talking about the mean claim payment, and so you want to answer your question also using the appropriate units. Well, I hope you've found this video helpful. Again, I'm just trying to help you think about how you can sort out your thought process, so when you are faced with a question with all of these different topics that were presented pretty close to the same time, you're able to determine what to do and then how to finish out and get the appropriate method and solution for the question that is asked.